So we're finding all the zeros of those functions that I wrote up there. Okay, or those, they're just expressions right now. I could set them all to 0. That would probably be the proper thing to do here. If we want to find all the zeros, what does that mean, find all the zeros?
Solutions.
Find all the solutions. What does that mean? Sometimes where they cross the x-axis, specifically if they're what type of solutions? Real, yeah, okay, because any real solution is going to cross the x-axis like you're saying, okay? The first one, how many zeros will there be? 3, how can you tell? It's the highest power, that's the degree of the polynomial. Number 2 will also have 3, and the third one will have 4. Okay, so you should know how many there are based on the highest power that you see. Now, if you had a problem that was as easy as this, and I said find all the zeros of this one, what would you do? Factor it. X minus 9, x plus 4. So what are my zeros? 9 and negative 4, right? So in an ideal world, if you can factor it, that's awesome. You're done with the problem. My two zeros would be x equals 9 and x equals negative 4. You should be able to draw a pretty good graph of this now. You know it crosses the x-axis here, it crosses the x-axis here, and what shape will the graph be? Parabola. Okay, you could draw a rough sketch. Okay. It'd be rough because you didn't plug in any other values for x to, see what the minimum is and blah, blah, blah. But you can at least make it hit the zeros at the right locations. Okay? Now, the one I gave you here, x cubed plus 6x squared minus x minus 30 equals 0. Do you know how to factor that?
Nope.
Okay, Lainey says no. Anybody else? Maybe? By the grouping, we tried it. I didn't get it to work by grouping. Did not get it to work by grouping. So what's another method you can use? Graph it. Okay? Go ahead, graph it real quick. You can't tell what the zeros are by looking at the function, or you don't think you can factor the function, then go to your graphing calculator and see if you can find the zeros on your graphing calculator. This would be a great opportunity for all of you to make sure you know how to use the graphing calculator to find zeros so you're not asking on a test how to use a graphing calculator.
I haven't given this one.
I just write
Just like a straight line. Oh.
Any luck?
Still a straight line.
Maybe, what'd you find? I think I wrote it for, so all three of these were nice. Negative 5, negative 3, positive 2.
Yep.
I heard another one.
Yeah.
I see 3. So x equals negative 5, x equals negative 3, and x equals positive 2. Okay? So, some of you maybe are still struggling with your calculator. The way it sounds, right? If you were not able to find those. So found on calculator. To find the zeros, I probably don't even use the graph, guys. I'll use the table. So is x cubed, then what will help?
6x squared.
Plus 6x squared minus probably just use the table. What am I looking for? Where the y value hits 0, right? So I can see -5 right here, I can see -3, okay? So I got -5, I got -3, I know there could be one more somewhere, so I kind of do a little searching around. And there's the last one at 2. So -5, -3, +2. I could confirm it kind of by looking at the graph, that looks about right, okay? Here's a -3, here's a -5, there's a +2. So we found all the zeros simply by looking at the graphing calculator. Alright? You can do that. If the directions say find all the zeros and you find all the zeros on a graphing calculator, sweet. Move on to the next problem, you don't have any extra work to do. Okay? How do you know that's all of them that there are? 3 is the degree, 3 is the highest power. You know there is only 3 zeros, there is only 3 roots, there is only 3 solutions, okay? So that's it, you're done. You don't have to do anymore. The directions say find all the zeros, we know there has to be 3 of them, you found all 3, you are done with that problem. Any questions on using a calculator to find zeros? Anything at all? Calculator issues? Yeah, I mean on the calculator they're not always, you can't always find them on the calculator though. But if you can find all of them using a graphing calculator, you'll like that problem because then you're done. But were you able to find them? Great. Okay. The next one you can't. So that's kind of why I wrote different problems up here. Okay. On the next one, x cubed minus 2x squared plus 9x minus 18 equals 0. Again, find all the zeros. How many should there be? 3. Can you factor that one? I think maybe you tried to factor by grouping as well here. Didn't quite work. Okay? Actually, I think it didn't quite work because you wrote it wrong. That's why it didn't work.
I hate
This one could be factored by grouping. Okay? Now that I see that, it's going to make your x minus 2's work out. But anyway, little help calculator. Did you find any?
No, there's one.
There's one. What is it? X equals 2. So on the calculator, we found x equals 2. So we found one of them. But there weren't any other ones? Look at the graph. How many times does it cross the x-axis? Once. So that means there is only one real solution, and the other 2 must be imaginary. Okay, they'll have an I in them. Does that make sense? Remember, imaginary roots always come in pairs. Imaginary roots always come in pairs. And you'll kind of see why with this example. Okay? Now,
Are you going to talk about what's plus C?
I will, yeah. Yep. I don't know if we'll get to it today, but yeah, definitely. Let me go back a second. Here was our polynomial. We found all the zeros on the calculator. What if I asked you for the factors of that polynomial? Could you list the 3 factors right now? You should be able to. X plus 5, x plus 3, and x minus 2. If you said something different, I misheard you. Okay? These would be the factors. If I multiply these 3 factors together, what do I get? Right up here, right? My original polynomial. If you know the zeros, you know the factors. If you know the factors, you know the zeros, vice versa. Yes? No? Everybody on board with that? If you know the zeros, you know the factors. If you know the factors, you know the zeros? Okay? Alright. So now let me come to this one here. We know 1 0. So then we also know 1 factor, don't we? So we know that x minus 2 times something has to equal x cubed minus 2x squared plus 9x minus 18, right? Because we know x minus 2 has to be a factor. So x minus 2 times something has to give us this polynomial. Well, if I said that 7 times something equals 714, what would you do? Set it equal to, and then how would you solve that? Divide? Yeah, you divide, right? If this times something equals this, to solve for that something, wouldn't we divide both sides by x minus 2? To figure out what this is right here? So we need to be able to take this polynomial and divide it by x minus 2. So we're going to take x cubed minus 2x squared plus 9x minus 18, and we're going to divide it by x minus 2. Do you remember dividing polynomials last year? You did two methods, I'm guessing. You did long division, which is not very much fun, and then you did synthetic division. Okay? That's what you're kind of seeing on that worksheet with that one example there that I showed. Okay? In order to divide polynomials, the easiest method is to use synthetic division. Okay? Synthetic division works as long as the coefficient in front of the x term is a 1. Okay? Which it will be majority of the time for you. Okay? I won't force you to do any long division. Alright? So here's how you do synthetic division. Here's a little refresher. I'm dividing by x minus 2. Because 2 was a 0, right? 2 was a 0, so x minus 2 was a factor. Whatever the 0 is, I kind of put that in just kind of a little box right up here in the top left-hand corner. And then I write the coefficients of my polynomial just to the right of it. 1, negative 2, 9, negative 18. I draw a line a little bit underneath that, and now I'm going to do the process of synthetic division. Here's the process of synthetic division. You take that leading coefficient, you drop it all the way below the line. This is just a process. I'm not really going to go over how it works. I can show you by doing long division, but you're going to come back and do synthetic division anyway. You take the leading coefficient, you drop it below the line. Take notes as you need to. Take the leading coefficient, drop it below the line. Take that number times what's inside the box and put it just underneath that next number, that next coefficient. So 1 times 2 is 2, I put it right here, and then I add those numbers together. Negative 2 plus 2 is 0. And then I repeat the process. I take this number times what's inside the box, 0 times 2 is 0, put it right underneath here, add them together. Repeat the process one more time. 9 times 2 is 18, put it right here, add them together. If you don't get 0 at the end, you did something wrong. Okay? This number back here is kind of like the remainder. Remember how when you used to do division, there's a remainder if it didn't come out evenly? Well, this is a factor, right? Don't factors go into things evenly? So when you divide something by a factor, it better come out evenly, so you better get a 0 there, or you goofed up on your synthetic division. Okay? So now what do these numbers mean? Okay? Well, they're the coefficients of your answer. I took an x cubed polynomial and I divided it by an x. So these answers are the coefficients of the expression that would be left over after we divide, except we start with 1 less power than whatever it was here. So I had an x cubed, I had 1x cubed, now I have 1x squared, then I have 0x, and then I have 9. So really just x squared plus 9 would be my answer. So when I took this polynomial and divided it by x minus 2, out came x squared plus 9. So what would happen if I would take x squared plus 9 and multiply it by x minus 2? I would get the polynomial that I had at the beginning, right? Okay. But the whole purpose of this is to figure out the factors of the polynomial, because if I know the factors of the polynomial, I can find the zeros of the polynomial really easy. Okay? I'm going to go on my next screen here. So right now I have the factors x minus 2 and x squared plus 9, right? Those are the two factors of this polynomial right here. If I know the factors, how do I figure out the zeros? Set the factors equal to 0 and solve. Obviously we already know this 0, right? We found it on the calculator, it was x equals 2. X squared plus 9 equals 0. Do what to both sides? Subtract the 9. Square root both sides, and you find the pair of imaginary zeros, and they would be a positive and a negative 3i. The reason imaginary roots will always come in pairs is because to find them, you will be solving a quadratic equation. Quadratic equations have two solutions. That's why they'll always be in pairs. It'll always be with its conjugate in a sense. Okay? So all of the zeros on number 2 here would be 2, positive 3i, and negative 3i. If I plug a 2 into this function for x, out would come a 0. If I plug positive 3i in for x, out would come a 0. If I plug negative 3i in for x, out would come a 0. These are the three zeros of that polynomial. Okay? Next one. This one's easy. Because I'm saying it's easy, it must be what? You must be able to do it how? Factor. Yep, you can factor this. You have a trinomial, 3 terms, just like when you have x squared plus 4x minus some constant, okay? You can break it down into 2 factors like this. What times what gives you x to the 4th? X squared and x squared, right? What 2 numbers multiply to negative 64 and add to 12? 16 and negative 4, good job. Plus 16 and a negative 4. Can any of those be factored further?
Yeah.
The one to the right, the x squared minus 4, can be broken down into what 2 linear factors? X minus 2 and x plus 2. One's plus, one's minus, because that's the difference of 2 perfect squares. So I can't do anything with the first one because it's not a difference of 2 perfect squares. If that was x squared minus 16, I could factor it further. But x squared plus 16, it's the sum of 2 perfect squares. You can't factor that any further. The difference of 2 squares, you can factor further. Now, to find all my zeros, what should I do? Set them all equal to 0 and solve. This one takes a little bit of work, but some of you are probably going to do that in your head, and that's okay. I'm going to subtract 16 from both sides, and then I'm going to square root both sides, and I get what? Plus or minus 4i. So there's 2. X equals positive 2. X equals negative 2.
Can we write that as plus or minus 2?
You certainly could. We found all 4 zeros, which we expected there was going to be 4 of them because it started by being raised to the 4th power. Okay. If you were to graph this function, how many times would you see it cross the x-axis? Twice, here and here, because it only has 2 real solutions and it has 2 imaginary solutions. Okay. synthetic division, you'll have to use that on some of these problems for sure to help you get it down to a quadratic factor. You also may have to use this. Right? Or you can always complete the square. But you may have to use that. Right? She said, how do you complete the square? You can't solve this quadratic by factoring. So in that case, you have to use either the quadratic formula or completing the square. To complete the square, I need to make this become a perfect square on this side of the equal sign. So to make this become a perfect square, I need to take 8, cut it in half, which is 4, square it, which would be 16. So I need this number to become a 16, so I have a perfect square. So to make this become a 16, I would add 10 to both sides of the equal sign. So x squared plus 8x plus 16 would equal 10. I just added 10 to both sides. Now this is a perfect square. It would be x plus 4 times x plus 4, or in other words, x plus 4 quantity squared. So I made the left side become a perfect square. I've completed the square. That's what we mean by completing the square, making it become a perfect square. Then you square root both sides. So x plus 4 equals a positive or negative square root of 10. You subtract 4 from both sides. So x equals a negative 4 plus or minus the square root of 10. Those would be your 2. But you would have gotten the exact same thing by doing the quadratic formula. Some people just didn't really like this method, so you use the quadratic formula. Okay. To solve quadratic equations, if you can't factor it, you can always complete the square, or you could always use the quadratic formula. Okay? What I would recommend for the time being is practice finding all of the zeros on this worksheet that I gave you. Okay? The answers, I believe, are on the back. You should be able to do all of them up until 13, because 13 has some multiplicity in it, and I haven't gotten to multiplicity quite yet. But the answers are on the back. I even kind of showed you how to do synthetic division a little bit on there, so you can, or I did an example of synthetic division so you can see it. Okay? I want you to do 2 things with these. I want you to find all the zeros, but I'd also like you to write it in factored form. So what I mean by that, it's just to make sure you have a good understanding of what factored form is. So if I said find all the zeros and write it in factored form, I kind of did that all in one here. Here are all the zeros. There's factored form. Okay? Here are the zeros. This would be factored form. Okay? Just so you can kind of see the connection. Even on the first one, I found all the zeros on my calculator, but if I said to write it in factored form, that would be it right there. Okay? So practice up on finding zeros, writing them in factored form. We'll continue to move forward with this on Thursday. It would be very helpful if you completed a few of these before Thursday.